Okay, so actually, what is quantum physics? Quantum physics is different from classical physics because classical physics is all about classic. Classic physics is all about macro world. Okay, for example, whatever you see, whatever you can touch, you can feel, outside of air particles, atom, outside of molecule, it's about classic physics. Because a long time ago, they don't have enough techno, don't have don't have enough technology support the survey. But now we got electronic microscope to observe the particles. That's why now we can study about quantum physics. It's all about electron inside the atom. Okay, it's all about proton, electron, neutron. Okay, so we thought electron is the smallest subatomic particles inside an atom. But actually it's not. Okay, recently the scientists find out there are another things called quark. Quark exists inside, even smaller than electron. All right. Okay, so now, actually we should learn what is black body first, but never mind, we learn the history first. Okay, classical theory. So must memorize them. For classical, for quantum. Okay, first of all, actually they already summarized for you quite easy. Quite easy. First is Isaac Newton. In 1643 to 1727, it's in 7th century. This time is in our Malaysia is about penjajahan. Portuguese already done. Next is Belanda. Now we are under Belanda. Okay, Isaac Newton in 17th century already invent an idea. The idea is particles nature of light. Okay, he said light is a particles. Do you agree? You might not agree as me. I was shocked. Huh? Light is particles, man. Because from 4 we learn what? Light is a wave. Mana ada particles? No way. Okay, so, and then also he cannot explain the phenomenon of light, got refraction. So he said light is particles, but no proof to support. Okay, then Thomas Young. Thomas Young say what? Thomas Young, he carried out a double slit experiment in 1801, and he showed that light is a wave. Okay, so Thomas Young proved the light is a wave by double slit experiment. What is it? You might forget, so I want to show you the fit simulation. Y'all can go search this PHET. You can see there wave interference. This is what we learned last year, chapter 5, Form 4, chapter 5. Okay, double slit and one slit, two slit, and this is the wave. Ta-da! Double slit. See what happens if I move closer, the D closer. Sorry, D is from here to the screen. Okay, then let's say like this. Split width and make it smaller. I'll make it smaller. Slit separation wide. Okay, I post this. So can you see that here got something called apa ni? Crest stroke. So here will form a antinodal line. Antinodal means you will see this part is bright. You can see the bright light. Then here also, so antinodal line. And then this part is like blur, nothing here. So actually this part we call it as nodal line. Nodal line. So this is called interference of light. Shows what? Shows light is a wave. Oh, this is water wave. Okay, maybe I change to the light. The light. Double slit. So you can see this is clearer. You can see this part bright, dim, or dark, bright, dark, bright, dark, bright. If I change the frequency, means I change the color. See what will happen? The X changes. All right. But today we are not going to study this. Just that Young, Thomson Young, is it? Yeah, sorry, Thomas Young. Thomas Young, he used the double slit. Double slit. This is light, and he used a double slit to prove that light is a wave. Okay, then same as you. Yeah lah, light is wave. Right? I proved it last year. Okay. Then come to John Dalton. So you learn chemistry. So almost the same year, in that century lah. Not same year like at around that time lah. John Dalton find out, an atom got atomic model. So matter consists of basic particles that cannot be further divided called atoms. So same element have the same type of atoms, but still unable to explain the light spectrum produced by atom. Apa itu light spectrum produced by atom? Okay, this is about okay, we thought, okay, light spectrum. At that time, they already find out light spectrum. Apa itu light spectrum? Is this. Okay, so we thought the light is, the white light contains 7 colors. Remember, I told you how to remember. Roy give birth, okay? Roy, orange, yellow, give birth, B-I-V. Roy give birth. Okay, we thought the spectrum is continuous. But the atom, when they observe, the atom give out the light in this way. Not continuous. Sometimes got one, sometimes got two. Sometimes the distance not the same. So this is called line spectrum. This is called light spectrum. And we also can call it as a packet of energy. A packet of energy. Okay, packet, like you bought a packet of sweets. Inside got different sweets. So the light, the atom will give out the light like this. So this is called a packet of energy. So this is the okay, then we continue how they solve this problem. Okay, John Dalton say, particles is an atom. Okay, then now come to J.J. Thomson. Yes, see, after Thomas Young and John Dalton, he discovered electrons. Oh, inside the atom got electron. So he find out inside the atom got negative charge as subatomic particles. So he called it as electron in 1897. So see, from here to here are already around 90 years old. 90 years. From here to here is around 200 years already. All right, now design experiment to study the behavior of electrons, but still unable to explain the line spectrum of light produced by the atom. Means the atom will give out light in a spectrum, not continuous. Why? Don't know at that time. So now, because of them, so build up the basic of quantum, then we come to the quantum physics. Okay, so now Max Planck. Thanks to Max Planck. And don't think this is their real photo. So actually, young Max Planck is quite handsome. Max Planck. And he turned like this. So we can get one conclusion. If you use your brain too much, you will become bored. No, I'm just kidding. Okay. But anyway, I should put young. Maybe he find out this when he was aging lah. So okay, Max Planck. Okay, he lived until 1947. It's quite close to our time now. Okay, so actually, quantum physics, he introduced the concept of quantum in 1900. So means from the concept of quantum from 1900 until now is nearly 120 years only. Okay, very, very short compared to Newton's time, the classic physics time. Okay, then because it's very, very new, so no one can say they really understand quantum. Okay, even Albert Einstein and Louis de Broglie, in French, they I think pronunciation is Broglie. or whatever. But some people will pronounce in English name Broglie, Louis de Broglie, whatever. As long as we can spell correctly. Okay, so at that time they still argue to each other. And one more person, what is it? Schrödinger. Okay, so now come to Max Planck. Max Planck, he introduced the concept of quantum. What is the meaning of quantum? Quantum means discrete energy. What is the meaning of discrete? Discrete means separately. Separate. Like the energy, discrete, one by one, not continuously. Okay. So he said that the electromagnetic wave, like light wave, like light wave, emitted by the black body is in discrete form, known as quantum of energy. Then you might ask me, what is black body? Is it black? Okay, this one later. Later we tell. It's not necessarily black. Okay, so means the atom will give up the energy in discrete energy, and normally it is in a package. Okay, the energy in each quantum is directly proportional to the wave frequency. Okay, so the energy depends on the frequency. So the intensity of radiation is low for the high frequency waves. Okay, so now you need to remember what he introduced quantum. So write quantum on his head. Okay, then come to Albert Einstein. 1900, he introduced the concept quantum. So Albert Einstein and then introduced the photon concept in 1905. Okay, what is photon? Photon is energy. So please write photon on his head. Photon energy. Photon is an energy. Why my word disappear? Okay, yeah. So bear in mind, photon is an energy. When I say photon, I'm not saying photo. I'm saying energy. I'm saying a package of energy. Okay? So this energy is directly proportional to the frequency of the light. Apa itu? Means the frequency for example, the frequency, yeah, this one, this is, yes, hi. This is violet light. Violet light got shorter wavelength, means higher frequency. This is red light. Red light means it got longer wavelength, means lower frequency. So Albert Einstein said the photon energy depends on the light, okay, the light color, or the frequency of the light. Okay, so he introduced Einstein quantum theory of light, was successful. So now come to he solved the problem of here, what they say, the behavior of electron. So, Einstein's quantum theory of light was successfully explain the characteristic of photoelectric effect that could not be explained by classical physics. Okay, question mark first. Apa itu photoelectric effect? Okay, now you just need to remember photon energy by Albert Einstein. Okay, now comes to Niels Bohr. Niels Bohr. Niels Bohr explained the production of line spectrum. Now, line spectrum. This is line spectrum. Produced by hydrogen atoms. Apa itu hydrogen atom? Okay, now come. This is an atom. We give one proton. It will be hydrogen. So, one proton, one electron will be hydrogen. And then you find out why this atom will give out light. Okay, so he said that when electron in an atom orbit around its nucleus on the certain shell, the transition means movement. Movement of electrons from high energy level shell to a low energy shell will emit photon. Still remember what is photon? Photons is energy. How is the photon energy looks like? Ta-da! Like this. Okay, means what? Means here got two layer, right? Here got two layer. So this shell, when electron move from one shell to another, okay, when it go up and when it drop back. When it drop back, it need to release out energy. So how the electron release out the energy? It will be in this form, in the line spectrum. And then he find out different atom will release out different line spectrum. Right? Release out different line spectrum. So this is what Niels Bohr said. He introduced it. Then okay, it solved problem. Very good. Until here, Louis de Broglie, French. Okay, he introduced the hypothesis on the wave nature in 1924. At that time, Malaysia still under British control. Japan not yet come. Our independence on 1957. All right. So Einstein and de Broglie postulated the idea of wave particles duality of light and all subatomic particles. Okay. Right. Means the light can be a wave and can be a particles. So yes, what Newton said here is correct. What Thomas Young said here also correct. Yeah, light got two nature. Got two nature, so we call it as wave particles duality. Okay, so now Niels Bohr say what? Niels Bohr say electron. Apa? Emits photon. electron transit emits photon. Electron transit. Transit means move, then release photon. Emits photon. What is photon? Energy. Okay, then Louis de Broglie and Albert Einstein, they come up as a conclusion, a summary. Light has, so we say the wave particles duality. Okay. Now it's your turn. What about memorize? Okay, very easy. Classical theory, they already classified for you. Isaac Newton, particles of nature of light. He said, light is the particles, but no proof yet. Thomas Young said, light is a wave by using double slit experiment, which is this double slit experiment. Then come to John Dalton. He said everything made up by atom. So you remember atom. And this is particles, this is wave, this is atom. Then J.J. Thomson's discovery, the electrons. Okay, so here now. The basic of quantum physics already introduced. I mean the key to open the door of quantum. The 4 keys already here. Light is particles, light is wave, atom, inside got electron. Now the 4 keys is here, then open the door of quantum. So Max Planck introduced quantum concept. What is quantum? It is energy, discrete energy. Discrete like this. Discrete like this. Then Albert Einstein introduced, based on the quantum, he introduced up the quantum energy as photon energy. Photon. So when I say photon, directly you get it. The word photon means energy, but not one energy. It is a package of energy. A packet of energy. Then Niels Bohr say when electron transit, electron move up and down and it will give out photon. Means give out energy. Not give out, emits photon. Finally, come to Louis. Normally, most of the people call him de Broglie. Okay, de Broglie as wave particles duality. Wave particles duality. Proof that Isaac Newton and Thomas Young are right. Okay, I give you 3 minutes, then close your book, then I call your name, you tell me. Just tell me one key. Already okay. Tell me one key already okay. All right, 3 minutes. Any question? No, okay, 3 minutes. Huh? Okay, like look at this. Our book. Okay, like tell me the key for Isaac Newton. Like Donna. 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 Particles of nature of light. Yeah, particles nature of light. Okay, good. Means light as particles lah. Particle natures of light as particles. Like Thomas Young say what? Like Chun Pai. John Dalton say what? Like Jun Wei. Jun Phai, Jun Wei. J.J. Thomson say what? Like Ming Fu. Like Max Planck say what? Like Esau. Like Albert Einstein say what? Rene. Like Niels Bohr say what? Kai Xuan. Louis de Broglie say what? Liu Guang. Hai Chun Fai. No, not radiation of black body. Cannot explain. Yeah, double slit experiment. Double slit experiment means what? Means light is wave. Okay, Ranny Chan, Ranny, yeah. Okay, Ranny say what? Ranny say Albert Einstein say photon. He introduced the photon as energy. Okay, then Yu Guang de Broglie say wave particles duality. Okay, then Hai Xuan and then YS is who? YS Yisong. Yisong. I thought you like. Oh, Kai Xuan. Kai Xuan. Electron in an atom orbit around the nucleus. Correct. Electron, yes. Yeah, in chemistry, say electron is orbiting the nucleus. But here, he said when electron move, let's say electron moves up, and when it jumps down, it will release energy. It will release energy. This energy we call it as photon. Okay, when it transmit up down, not up down, from higher energy shell to lower energy shell, it will emit, means release photon. Okay, nail balls. Introduce electron, okay. Then Jun Wei say, John Dalton light spectrum. You wanna die, are you? John Dalton, the father of chemistry. The father of chemistry, atom. He introduced atom. Atomic model, atom. Atom means atomic model. All right. Then so quantum black body and energy is directly proportional to the wave. Okay, good. He introduced quantum. And this quantum is directly proportional to the frequency of light. Yeah, very good. J.J. Thomson 呢 Manfi Minh Phu, sorry, Minh Phu. Minh Phu, Minh Phu put 在 Yeah, J.J. Thomson is here. Discovery of electron. What? Sorry, John Dalton, is it? Eh? Am I doing something wrong? J.J. Thomson just introduced electron. Okay. There is electron surrounded inside the atom. John Dalton said, there's atom. Then J.J. Thomson said, inside the atom got electron. Okay. So the rest you all can refer to answer lah. And refer to answer, just copy the answer. Okay, what you need to do is just remember the key, because normally I seldom see this question. Just I guess maybe objective may have one. Okay, may have one. From Isaac Newton, Thomas Young, John Dalton, to J.J. Thomson, classical physics. And quantum physics starts from Max Planck, Planck, Albert Einstein, Niels Bohr, and De Broglie. Okay. And just now we got two question marks. What is a black body and what is a photoelectric effect? This one later lah. After this, we come back to the black body first. Okay, the black body. Quantum theory of light. Okay, in Foot 4, you learn that electromagnetic spectrum is a continuous spectrum. This spectrum consists of 7 types of wave with different frequency and wavelength. Okay, so this one have you memorized? It's a must, It's a must to memorize. Not only used in the chapter waves, but also used in this chapter 7. Okay, so if you want, you can remember in this way. Do you like money? There is money inside the spectrum. RMIVUX gamma. Ringgit Malaysia, I love you, X gamma, right? It's a must. Yeah, it's a must. Alright, then visible light. Okay, for Chinese, normally no problem because we already memorized since primary school. Okay, but I find out other races, sometimes they don't memorize. So you must memorize. So here, this is R, red, orange, yellow, green, blue, indigo, violet. Not purple, violet. Okay, so here you can see is Roy give birth. Weird, right? Roy will give birth. Roy give birth. Roy give birth. 红橙黄绿蓝靛紫 I stand for indigo. Okay. And must remember the wavelength for radio and red is longer than another side. Okay, so the wavelength here for red, really long. RR, really long. For violet and gamma, right? So this one, the wavelength is short. Means what? Frequency is higher. We can use V equals to F lambda. So we say V over F equals to lambda. So we can say lambda is inversely proportional to frequency. That's why longer frequency, longer wavelength increase, frequency decrease. Then smaller wavelength, higher frequency, right? This is the basic lah, must know lah. Yes, teacher, is it alright if you can jumble a bit Chinese since I'm used to speaking? I think everyone here understand. Okay, no problem. After I explain English lah, then I explain in Chinese lah. Cause I believe before exam, many people will watch this. Now after exam, everyone relax already. And as I told you lah, actually I think still not many people realize that. And they think I will record their mind. Okay, so most probably November already starts our trial. December, 5th of December is our Amali, the real Amali. Okay, so now this is August, September, October, beginning of November starts trial. So how many more months we left? 3. 1 week or 5? 5 period. Okay. So 1 month or 4 weeks. So 12. So we only got 60 periods. We need to cover chapter 3, 4, 5, 6, 7. Can we cover it? I don't think so. That's why I start 7 first. Then 6. Then got time I cover 5. Okay, just hope can help you all. I don't think we can finish in the school. Some more we still got experiment. Chapter 3, at least 2. Chapter 4, at least 2. Chapter 5, I just demo. Alright, so not enough time for us. Confirm December. Not 1% not confirm that means 99% confirm that. So that's why I better start now. Okay, so okay. 你要讲什么？你要问什么？哪里不懂？你可以 on mic 啊，可以 on mic。很好，谢谢你。OK，所以记得红橙黄绿蓝靛紫 ，radio wave 就是 radio 什么？收音机，广播的波动。Just not used to use speak English. Actually, this video for everyone in Taman C or other school. Okay, so now this one, the basic already here. Now come to the black body. Okay, now first of all, we look at this sentence. All objects emit electromagnetic radiation. Cold objects also emit wave with low frequency. So while hot objects emit wave with higher frequency, such as visible light and ultraviolet radiation. Okay, so that's why under the hot sun, you will feel the light very shiny. So you put cap on. But when you put cap on, you still will get tan. Why? Because there is UV. Actually, UV got UVA, UVB, UVC. So when you choose your sunblock, you must make sure you choose the sunblock got PA++ at least 2+. Means it will protect from UVA, and then SPF, sun protection factors. Okay, actually, what is so 30 at least? Apa ini? So actually is if you stand under the sun 10 minutes will make your skin become burn, become red. So SPF 30 will make it become 30 times. So 300 minutes divided by 60, it will be 5 hours protection. But if you sweat or if that one become thinner and thinner, yeah, you need to sapu again lah. Then at least these two lah. And why I don't say C? Because C already absorbed by the ozone layer, so the C cannot reach on the earth, right? So remember, choose sunblock. No matter boys or girls, apply sunblock, okay, to protect yourself. Okay, black body is an idealized body. Means it is ideal. Means it's 100% work. So we cannot find in real life lah, but just idealistic lah, that is able to absorb all electromagnetic radiation, means light or all of this lah, light or all of this lah, all of these are electromagnetic lah, that falls on it. A black body can also emit thermal radiation. It's UVB. B stands for burning. A stands for aging. Burning. So you feel, oh, it's burning. It's UVB. Then you feel, oh, why my skin got the black spot? That's UVA. Okay. Depending on its temperature, the radiation emitted forms a continuous spectrum and is unaffected by the nature of the black body's phase. Thus, an object emitting electromagnetic radiation which is determined by its temperature is known as black body radiator. What is radiator? Radiator means it will give out, it will release out, it will emit something out. Emit the radiation, emits the light or the heat. Okay, so here is the explanation. Thermal radiation is electromagnetic radiation that includes visible light and radiation that cannot be seen by a human eye, such as infrared. Okay, so you can see it shines out light, or you cannot see anything, but you can feel it. Oh, it's hot. So that's black body. It will emit radiation. Is black hole and black body? No. Yes or no? Yeah. Sorry, yes, because the black hole will emit out gamma ray and X-ray. Yes. So actually, what is a black body? Black body not necessary is black, as long as the object can emit 100% of EM wave, electromagnetic wave, and release out, or we say emits out 100% of the wave. but this is idealistic 啦。Emit 是放出来 release，这是 absorb，这是 emit 是 release。谢谢可轩。Release 通常是讲 air 啦，通常是讲 air。Emit 是放射出来，放射出来，通常是讲光 emits light 或者 heat，就是 emit energy 的意思。Release 通常是比较有 particles 的。emit 是 energy，就是讲吸收了100%发出100%，对 emit is ray，thank you Rennie。idealistic 啦，但是因为 idealistic 嘛，所以你如果 absorb 98%，你 emit out 90%，它也算 black body 啦，可能95。OK，来，我们来看，比如讲我们的 ear cavity，the rays of light enter the ear cavity will undergo repeated reflection in the inner walls of the air cavity. At each reflection, parts of the ray are absorbed by the inner walls of the ear until all the rays are absorbed. Thus, the ear cavity acts like a black body. Not necessarily black, as long as it can absorb all the EM waves. Normally, here we say light lah. We say light lah. We say here we refers to either infrared or visible light or ultraviolet lah. Others wave we don't study first. We just study what we can see first. Okay, so as the temperature of object rises, object acts as black body radiate. Radiate means radiates and emits thermal radiation of all wavelength. So 7.2 shows the graph of radiation intensity against wavelength of 3 types of black body at different temperature. Usually every curved graph of black body spectrum is narrower on its left, which is an area short wavelength and high frequency. With increasing the temperature, the wavelength approaching maximum radiation intensity will also get shorter. Okay, what is intensity? Intensity means the brightness lah. The brightness. Can say the brightness lah. So actually in Form 4 we learn one unit called light intensity candela. Candela. Okay, so it's luminous intensity. Okay. How bright is it? Okay. So the radiation intensity is high on the left, means here. And ultraviolet ray here is the highest. So what? So here is red, here is, sorry. Here is the red, here is infrared, here is violet, here is ultraviolet. So you can see ultraviolet ray will give out the highest radiation intensity. Why? Because wavelength decreases. Wavelength decreases means frequency increases. This is what quantum and photon, the Planck and Albert Einstein said energy is directly proportional to the frequency of light. So this graph, they do experiment and they record. Oh, the higher the frequency, the higher the intense radiation. Radiation means it emits up in the higher intensity. Okay, then so the graph like this. Okay, then look at the hot object. For example, now this is a car in thermographic image. So you can see that red is not hot. Okay, wait, red is hot. Sorry, red is hot. These two have different brightness. Okay, in different temperature. Okay, so black body means something can absorb and emit light. Light UV. Light and UV. We concentrate these two first. Light and UV. Absorb, emits. Absorb, radiates, emits. Alright, now. Okay, so the black body, your body. Now, so here this is visible light, this is violet, this is violet, this is red. So this is ultraviolet. This is infrared. Something wrong here, please correct it. Ultra means more than. Ultra means more than. Infra means less than. Apa itu more than, less than. Frequency. Ultraviolet means the frequency of this wave is more than violet. Infra means the frequency of this wave, this EM wave is less than the red light. Okay. Okay, so you all answer this lah. Blah blah black body. Number 3. A black body is an idealized body that can absorb. Absorb all EM wave, electromagnetic radiation that falls on it. Absorb all electromagnetic radiation. Okay, the black body's radiation can be studied from the graph. So you can see that here is red light. The maximum would be UV. It will give out the highest temperature. We got the red very low only, the intensity. So will they ask candela in exam? No. I thought they would introduce here, but not yet. Just remember intensity. Okay. Because in Form 4 time, I first see this. Whoa, intensity. I thought Form 5 they would mention, but they don't. Good luck, you all exam less a bit. Okay, so now add blah 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 blah. Okay, just copy answer. Okay, copy from your answer the theory part. Now, what is the meaning of quantum energy? Okay, so come to the textbook. Okay, quantum energy is discrete energy packet and not a continuous energy. Is discrete means separate energy packet. Okay, now like this packet. So what is the function of this energy packet line spectrum? So we can use it to determine the determine the element inside the substance without destroying it. Okay, like you want to carry out so many experiments, chemistry experiment, right? So chemistry experiment is normally you need to cut them and then you put in some solution, you mix it, cut it, then you see, oh, color change. Then, oh, I know this is something. But by using this one, the line spectrum of the element, so we just shine the lights and it gives up this spectrum, then okay, then no need to destroy the things. So it's good for find the proof of detective, then determine the element in the meteoroid and many things there without destroying it, without damaging it. Okay, so you can see here the light spectrum produced by excited atom in series carbon, blah, 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 blah. Each element produces a spectrum with a series of its own distinctive lines. Means same element, it will produce same line spectrum. So different atom, different element, it will give out another set of energy packet, another set of line spectrum. Okay, so what is quantum? Quantum energy is discrete, means separate energy packet and not a continuous energy. Okay, minimum lah. Memorize until here. Discrete energy packet. There if possible, not a continuous energy. Okay, so jot down here already. Quantum energy is discrete energy packet. Is discrete energy packet and not a continuous energy. It is the what quantity? It is the I'm not sure about this. Okay, so at least you remember up to here. If possible, you continue this. What is a quantum energy? Quantum energy means it is a discrete energy packet. Okay. So then, what is a photon? Photon are light energy known as photon energy is a photons are light energy transfer in quantum energy. No, exit in the form. Photons are light energy known as quantum of energy. No. Photon is light energy in the form of energy packet. Photon is light energy exits in the form of an energy packet. Or you just remember photon are light energy known as energy packet. Packet means you can see that got so many lines here. Some line very close, some line very far. So this is called a packet, discrete energy packet. Okay, packet. Oh, okay, 1 minute. And I ask you, what is quantum energy? It is discrete energy packet. What is photon energy? It is light energy known as energy packet. Okay. Lai Yisong, what is quantum energy? If you can on mic better. John Wei, what is photon energy?
Quantum energy is a discrete energy packet and not continuous
not continuous.
energy.
Yes, very good. 刚刚我浇水了。准微photon is a packet energy. Is a light energy in the form of packet energy. Energy packet. Light energy known as energy packet. So photon actually means light energy. Okay. So he introduced the formula to it's E directly proportional to F. What is E? E is energy. So the E here is photon energy. And then the formula here, formula is given in exam. So do not worry. This is formula. So when you get back your exam paper, paste this back into your book. E equals to HF. E equals to E directly proportional to F. So we learn this in maths, right? Like circumference of the circle is directly proportional to the diameter. So when we change directly proportional to the equal sign, then we can make it as pi. Pi is what? Pi is a fixed number, or we say it is a constant. Okay, so it makes a ratio. So C over D is pi, is a ratio. So here is the same thing. Photon energy is directly proportional to the frequency of the light waves. So when we change the proportion to the equal sign, we need to give it a constant. So this constant is 6.63 times 10 powers of negative 34 joules second. Planck, we call it as Planck constant H. Is given. Do not worry. Then you will see this. Don't you feel familiar? Yes, Form 4, Chapter 3. Gravitational constant. What is this? Form 4, Chapter 2. Gravitational acceleration. Okay. So let's solve one problem. Okay, so now what is E? Chun Fai. Photon energy, right? H is Planck constant. Planck constant. F is frequency of light. And the properties. Okay, then. Yeah, for example, okay, so we get E equals to HF. And because here they refers to wave. A light can be a wave and can be a particles. Next week I introduce you the Schrodinger cats. It's a short story only, or you can find through the video. The YouTube also can. Schrodinger cats. Okay, so we say V equals to F lambda. So F actually equals to V over lambda. Okay, so now if we substitute F as V over lambda, we will get E equals to H V over lambda. Then what is EMF? EM wave means they are lights. Means their speed would be the light speed. Where's light speed? Here. Chapter 6, light speed, C. So we substitute V as C. So we will get E equals to hc over lambda. Will you get this in formula list? Yes. E equals to hc over lambda. Yeah, they are related. See, F equals to C over lambda. Actually, it comes from where? Form 4, chapter 5. V equals to F lambda. Since the velocity of light is C, so C equals to F lambda. So F will equals to C over lambda. Okay, so actually in exam, you can use this to derive out number 5. So do not worry. Now, how to solve this problem? What is the wavelength lambda of a photon? When I say photon, what is photon? Discrete energy packet. If the light energy is this. So we use E equals to hc over lambda. So E is 3 times 10 powers of negative 12 equals to H. 6.63 times 10 powers of negative 34. 6.63 times 10 powers of negative 34 times 3 times 10 powers of 8 divided by lambda. So lambda equals to press calculator. This is the answer. Oh no, where's my answer? I didn't download it. Thanks, Rennie. 6.63 times 10 powers of negative 14. Can I get marks? No, because no unit. What is the unit for lambda? Meter. Very good. Yes, meter. Very good. Myself. No means wrong. Teacher, how did you get the value for C? Oh, it's a fixed value. C. C is light speed. C means light speed. In the formula list given in chapter 6, light speed. So this is the greatest formula in last century. Because of this, we have the atomic bomb. So it's in your computer, your calculator too. So 3 times 10 powers of 8. Light speed. This is called light speed. Okay, then all of the EM wave here. Mana EM waves? Something wrong with my computer. Okay, all of the EM waves have same speed. So we say C. Okay, then next it's about P. P means power. Okay, sorry, not power. P means momentum. Right, momentum. This one we continue next week lah. It's about here. Okay, so this is called photon energy, but because actually the light got wave and particles duality, means it can be wave and it can be particles. So when it is particles, we can count like this. Lambda equals to h over p. Okay, so what is p? P is momentum of particles. Remember last year? P equals to mass times velocity. Since light could be a particle, so we can count it as, we can count its momentum. So h is Planck constant is given. Planck constant. Lambda is the wavelength of the light. Okay. So finally, so we can see, okay, how is it come from? Okay, next week. Okay, so since we say momentum equals to h over lambda, so lambda equals to h over p. So this lambda is the broad wavelength. Okay, so today we learn how many formula. Number one, E equals to HF. Number two, C equals to F lambda. So F equals to C over lambda given here. Don't worry. 1, 2 given. Then, okay, so if we substitute, we will get number 5. Number 5. And then the moment here. Since we say light is the particles, so we can calculate the momentum. So momentum equals to mv. So we substitute. Then here, okay, here, so here, if n is the numbers of photon emitted per second. What is photon? Photon is energy, discrete energy packet. So emitted per second means energy per second actually is what? Energy per time actually is what? Is the power. So we can say power equals to energy over time. Okay? And we will learn this next week lah. So today until here only. So next week we will concentrate on the calculation, and the last part is photoelectric effect. Apa itu? Okay, photoelectric effect, then this chapter done. So because it's quite simple, just introduction of quantum. In exam, they cannot have long questions. Means it won't be essay question because it's hard to make it as a long question. So maximum would be short structure questions and objective only. It's very basic. So quite easy like this chapter. Okay. Then next week we can finish already. They all just talk about photoelectric, repeat and repeat and repeat. 要不然爆了，哈哈，没事，正常。Okay. So today what you have learned? Sejarah. Sejarah of classic. Today what you have learned? You have learned classical physics. Classical physics. There are 4 scientists. And quantum physics, 4 scientists. Just remember one keywords from these 4 scientists. Then we learn formula. E equals to HF. Then from here we can substitute C equals to F lambda, F equals to C over lambda. So we will get E equals to HC over lambda. And because of de Broglie, he said light is a wave and also a particles. Yeah, so we get lambda equals to h over momentum. Yeah, one more formula. Next week we will try this. But this week we only try E equals to hf. They are as wave. Okay. Another question? If no questions, then you can rest. Thank you, everyone. Bye-bye. 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 Welcome. Bye-bye.
teacher，
Hey, yes.
我还想知道为什么没有quantum physics 没有讲到 Heisenberg 之类的。
其实还有，只是因为这是 introduction 啊，8个已经够你记了，考试够你考就好了。
OK，
这只是 introduction，very 的 fundamental，好像一层皮罢了，所以就基本讲这8个。
就
这样
对我来讲，
嗯，
只是那个字很难记罢了。就我懂它什么意思，可是我记不到个英文字。
什么 de Broglie，I mean scientist 的名字啊
不是很像那种 discrete，然后还有那个
，discrete 是分
呃
开的意思，它是单独的。
呃
packet 就是它是一套，packet 是一套，一整套的单独分开的 energy line。
呃，
就是刚刚一直给你们看的这个 photon，其实就是
光子
那一 set 光，那一 set 光。对，我电脑最近一直显示不到啊，就是那一 set 光啊，那个叫 line spectrum，line spectrum 叫吗？
应该就没有其他字是记不到了，应该
所以只
因为
要记 quantum
记
这两个字，
记
重点两个字，要记它的 definition，其他不用记，不用记。
OK 没有东西了，谢谢老师。
不客气，OK，拜拜。